Hello. Yes. So today I've looked at some basic notations like Big O for algorithms, and I've also looked a bit into arrays and strings, especially the two pointers. So let's dive right into it. What is a two pointer? So basically, um, the idea is simple. So given you have a list, A, B, C, D, E. So there should be a quotation mark. Given a list of string or a number or whatever it is, it doesn't matter. Um, you place two pointers at the very end, or you can put it at any other index depending on the problem. But the basic is this. And depending on what the problem asks, you move the position of the pointer towards the other pointer, like this. And when it meets up, that could be the solution of the problem, given the problem is asking for that, or um, something else. And the reason why people use this is because, um, let's say you need to sort the reversely arranged string. Of course, in Python, there's a built-in function like sorted uh, that you can just wrap it around the function and does the job. But it takes a bit more time complexity because sorted is n log n. And if you just do it like this, using pointers, and to traverse all the elements, it only takes on. So it's a bit more faster, especially if the number of elements is smaller. So that's why people use this. And let's maybe do some problem. So I did two problems. First one was the one that I briefly explained about, reverse string. So basically, the question is asking to, yeah, give the reverse arrangement of the list of a string. So what I did is, like I said, initialize the left pointer by 0 and right pointer by pointing at its index. And whenever the left pointer is on the left side of the right pointer, you swap the elements at left and right indices. So you just simply swap the elements. So, for example, you got A, B, C, and D. You initialize left 0, right 0, and pointer is located here and here. So you swap the elements, so it should be D, A, B, C. You swap only the first and last element, and the pointer moves. I think I specified it here. Yeah, left +1, right -1. So it moves from here. Pointer moves from here. This pointer moves here. And now these elements are swapped. So it becomes D, C, B, A. Yeah, D, C, B, A. So reverse sort. It's pretty easy, right? Yes. And this is the core idea behind the two pointers problem. And we can do a bit more complicated one. I think it's this one. Yeah, I've also forgot to mention I built a test case. Um, Tried it on, and yeah, it is successful. So we're just gonna move on to the next problem. Yeah, this one, sorted squares. So what it asks for is basically given a list of numbers or integers, you need to square it and sort it. So basically, if you have -4, -3, 0, 1, 5, yeah, there should be commas and quotation, but we're going to skip that. You have to square it first and then sort it, or whatever you have to do. So what I used to do is using the brute force, I would just use the built-in squared function, or just double multiplication symbol, and then just use a sorted algorithm. But like I said in the beginning, it would increase the time complexity. So how can we solve this using a two-pointer approach? So basically, you initialize the left-right pointers like I did from my previous problem, and then you also initialize a list full of zeros, a blank list. Now you have to specify the position as well, and this is because you're not going from left and right side, you're only starting from the right side. So I initialize that, and while the left pointer is smaller than right pointer, so we can see that the square of, oh, I forgot to mention. So yeah, we define the left square, right square by square of the number that left pointer is pointing at and square of the number that right pointer is pointing at, and that if that left number is bigger than the right number, then we initialize the result array with that number. But as you can see, square of 5 is bigger than square of -4, which is 25. So given a blank list of zeros, you're going to initialize the right end element with a 5. Yeah. So this until here, it's doing that. And then you move the pointer to the left by one element, one index. And you do the same here, 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 here. And then it will give you the numbers. Oh, I forgot to square it. So this should be 25, and then it should be 16. Because if you compare the next element here, you're comparing this one and you're comparing this element, because the pointer only moved from the right end. And this will do it until the length of the list is exhausted. So length of the iterable. List is iterable, so yeah. And then that will give us 9, 1, and 0 at the end. Yeah. And if you print out this result, it will bring this if you apply it on this list. So yeah, that was the algorithm. It's pretty simple and seems very versatile. I've heard of this, but I've never used this before, so it was a nice occasion to just brush off the memory and learn it. I'm pretty sure there are more cases where we could use this, as this is like the real basic, but I'm planning to first go through all the algorithms and then try to apply it on the question bank. So yeah, we're gonna go through the algorithms first, and that was it for today. Thanks for watching, and hope to see you guys soon.